Welcome to Cryp version 3. This is Aaron Bittman, software developer. Before I demonstrate the program, I'll just give a brief explanation. I expect that you probably haven't seen other versions of Cryp, but just in case you have, I'll mention that the biggest change since version 2 is this. The guess function. Now you can tell Cryp to take a guess, not only when it first loads a puzzle, but at any time you want. Also in version 3, I added an About button, so you'll know what version you're running. I should also explain that this is the version of Cryp which I wrote in Python. I wrote another version of Cryp called Cryp Swing in Java. So with that explanation out of the way, let's get to the point. What is Cryp? Back in the 20th century, I enjoyed solving cryptograms in magazines like this one. Cryptograms are messages written in code. Specifically, they're encoded with a monoalphabetic substitution cipher. In other words, one letter in the English alphabet would be substituted with another letter or symbol. The message in code is called ciphertext. The plain English to which you translate the encoded message is called plaintext. So for instance, if a plaintext A is written as a ciphertext C, A will always be written as a C throughout the message. Of course, solving such problems with only a pencil can sometimes be difficult and tedious. When you guess that a ciphertext symbol represents a certain plaintext letter, you have to search the whole puzzle for all occurrences of that symbol to translate it to the plaintext letter. If you later change your mind, deciding that's not the plaintext letter you want to guess, you have to search the whole puzzle again to erase every occurrence of that plaintext letter you wrote. Obviously, that kind of task screams for a computer program to do the work for you. Furthermore, a computer can quickly search through a dictionary file and suggest to what plaintext words a ciphertext word might translate, based on whatever criteria you decide. So when I learn a new programming language and come up with projects for myself to get practice writing in that language, I often choose to write a program to help me solve cryptograms. I typically name this program Cryp, short for cryptogram. Look in my code and you'll find that I drew some of the code from this book, Cracking Codes with Python from No Starch Press. I revised that code heavily so that it works better, at least in the puzzles I tested. Of course, if you search the internet, you can find many cryptogram crackers that work better still. However, I feel that even many of the better programs leave much to be desired. Many of them are only text-based. They might try every possible solution for one word, and based on each of those solutions, try every possible solution for another word, and so on. That approach can often be a good beginning. But I find many such programs leave a lot to be desired. What if one of the words in the solution isn't in that program's dictionary file? What if another word that fits the pattern is in the dictionary file, so the program takes a wrong turn? What if there are several possible solutions in which the words fit but don't make sense when put together? I feel the need for a human user to intuit what direction to take and to guide the program accordingly. And to help that human user do the job quickly and easily, I feel the need for a graphical user interface. So let's use it. First of all, I'll just mention that even if you don't want to bother typing up a whole puzzle on your computer, this program can still help you by searching individual words. You can simply hit the Solve Word button, and you'll get an interface to examine one ciphertext word. I can enter one word here and now, and find all the words in the dictionary that fit that pattern by hitting the Solve button. I can search through these 65 results and try to guess which one is the most likely, but there are ways of narrowing it down. For instance, I can check the like exclusion option. Like exclusion is my own personal term, meaning that a letter cannot translate to itself. For instance, a ciphertext A cannot translate to a plaintext A. Several people have pointed out to me that there's no rule that like exclusion must apply to a cryptogram. However, I've never seen a professionally published cryptogram that didn't conform to like exclusion, so I see no reason not to check it, especially when it can narrow down the possible answers. So now when I hit solve, the program has narrowed the results down to 38 possible words. Another thing I can do to narrow down the possibilities is to tell the program that I know, or assume, that one certain ciphertext symbol translates to a certain plaintext letter. For instance, suppose that I've been working on the puzzle and decided that a ciphertext Y is an E in plaintext. I enter my plaintext E over the ciphertext Y and hit solve. As you can see, that guess really narrowed it down. I should also mention, for those of you without experience in solving cryptograms, that when choosing a word to solve early, it obviously helps if that word is long, but something even more important is to find a word with many repeating letters. I'll demonstrate. I'll hit clear to clear all the ciphertext and plaintext I entered, and enter a short word with repeating letters. As you can see, even without like exclusion, I get a short list. So this single word solver window alone provides the heart of my program, but of course, Cryp can do more than that. And by the way, in case you were wondering about that use puzzle option, I'll get to that eventually. Right now it's useless because I haven't entered a puzzle yet. So, let's enter a puzzle. Here's a file in which I typed up a few puzzles from an old cryptogram magazine. Now, a longer puzzle is generally easier to solve than a shorter one. A longer puzzle is more likely to have good starting clues and to have more useful cross-references to narrow down the possibilities even more. So I'll copy that long puzzle. Now, in my puzzle solver window, I'll hit populate and paste in the ciphertext. You'll notice that here too we have a like exclusion option, although I've found that when Cryp makes its initial guesses, like exclusion doesn't help. So I'll just hit OK. As you can see, Cryp has solved almost the whole puzzle, leaving us just a little bit of work to do. I can click on the plaintext space above the ciphertext letter and type the translation. If I choose a space above any ciphertext P and enter a B, Cryp will translate every P to a B throughout the message, so that in more difficult puzzles I can instantly see what consequences my guesses would have. Well, in this case, they're not even guesses, they're obvious choices. So, for a real demonstration, let's try a harder puzzle. Cryp's initial guess didn't go very far this time, but is it a good beginning? Let's find out. Let's start with this first word. If I click on any plaintext space in the first word and hit the Solve Word button, Cryp will immediately populate the Solve One Word window with the ciphertext word and the plaintext that we're using. I'll hit Solve. I'm not getting anything, but you know what? If this word truly ends in an apostrophe S, that might not appear in the dictionary, but the rest of the word without the apostrophe S might. So I'll edit that information. And try to solve it again. I don't think a sentence is likely to begin with any of these words followed by an apostrophe S. Well, there are only so many words that this could be. Well, even though this is a short list, it would be good to check for any known plaintext in the puzzle. For instance, in the puzzle, we're guessing that U is R. Therefore, no other ciphertext letter should translate to an R. So I want to tell Cryp that no letter other than U should translate to an R, and the same goes for any other plaintext filled out in the puzzle window. I can tell Cryp that by checking Use Puzzle. Okay, that narrowed it down to 4. Could the word be feed? If I click on the word feed and either hit the select word button or else just double click the word, the puzzle window will automatically populate accordingly. So again, I can immediately see the consequences of my guess. There's a 2-letter word that begins with F. Fee, fi, fo, fum. It doesn't seem terribly likely. How about heed? Since I don't think ha, hi, or ho is likely, and it couldn't be he because the E is taken, and that same reasoning eliminates weed, let's try need. Well, that might be no. That last word seems unlikely, but let's try it. Nothing. I think that Cryp's initial guess is a dud. So I'll start with a blank slate by hitting the clear button. So first of all, notice that on the bottom of the Cryp window, we get a frequency count of all the ciphertext letters, both alphabetically and in descending order of frequency. So it's clear that the most frequent letter occurs 10 times, and the second most frequent occurs only 6 times. With that great a difference, it's a pretty safe bet that the most frequent letter is an E. Now, when starting a puzzle from scratch, whether with a program or even with just pencil and paper, I often find an apostrophed word is a good place to start. This dictionary file has all the N''T words we're likely to encounter, so it's safe to say that if this is an N''T word, it's haven't. So let's try it. No. That gives us a 3-letter word ven, which doesn't exist. Therefore, I'll assume that the first word doesn't end in N''T, but in ''S. Now, that last word has a repeating letter, so let's try that. Even with like exclusion, there are many choices. But based on our guesses, we can deduce that the word has no E or S. We can say so to Cryp by checking Use Puzzle again. Ah, that really narrowed it down. So let's guess some of the more likely words here. Amazing? No, that gives us words like nem and ms. Anatomy? Now that looks promising. So the consensus here is that the fourth letter is I. But what about the rest of the word? Let's keep this window open for now. Oh yeah, in Cryp you can open multiple word windows and compare their results side by side. Bin seems more likely than keen. Yeah, if the word were keen, then the word buy would become kai, so forget that. So back in our previous word window, we can eliminate brains. So the most likely choice is chains. This is obviously have. Chains are forged. You don't usually say that chains are forked, fouled, or poured. Well, that was a challenge. I exercised many features of Cryp to demonstrate how to use them. But for most puzzles I've tried, I don't need them. Version 3 gives us a faster, easier way, which I'll demonstrate. If you watch my demo video of Cryp Swing version 2, you'll see me working on this puzzle to demonstrate using the word window. Because when Cryp makes its initial guess, yuck, Cryp obviously must have guessed that apostrophed word must be couldn't or wouldn't. And those are the only not contractions in the dictionary that fit. So I guessed that the Q is an S. At that point, I went on to make another guess and start searching for various words that fit. In that way, I solved the puzzle in 3 minutes. But is there a faster, easier way? Cryp just took a guess based on couldn't. Now, I'd like to say, hey Cryp, you know how you ventured a guess at the beginning? Well, I want you to do that again, only this time start with the premise that the letter I entered here is correct. I can tell Cryp to do that by hitting the guess button. Bam! Cryp correctly solved the puzzle, except for a few letters. And if my guess had proven wrong, I could have taken a different guess and let Cryp take it from there. And you can take it from here. Feel free to play with the features. And here's a bonus. I provided a program to do the reverse. Generate a cryptogram from plain text you provide. I named it by spelling Cryp backwards and calling it Pyrc. Just paste a quote here. Run the program. And Pyrc will generate a cryptogram for you. You can create test cases this way. And there it is. Feel free to peruse my code and feel welcome to give me any feedback on GitHub.